Okay, so assalamu alaikum everyone. I just want to show you that we have to take three case study. Previously I showed you just one case study. So this was all of us, we used the same circuit, right? So our circuit was same. So this was the source we were using. So now we are changing the source. So please look carefully that we will bring another source, not this one. So we go to the library. So this is the library, and then we just search program. For example, we just search program. So means we actually want to find the programmable voltage source. So once we search program, so this will come, and you see three-phase programmable voltage source. Yes, three-phase programmable voltage source. So we just bring it to our file. Okay, so now we bring this. So what we do, we just remove it. So we are just removing it, and we are replacing with this one. Okay, and then we also will add this part. You see the series RLC branch. Yes, so this one we copy, series RLC branch we copy, and then we put it here. So we paste, and then for each phase we add this one. Okay, so this is the initial part. Okay, so now this value we will change. See, if you look carefully, our value will be a very small value. So 0. Let's say 0001, and this one let's say 0.0000 also 1. Okay, so now we make this. So this one also same, means all is same, we just maintain same. So this is R 0.0001, and this is L inductance 0.401. So okay, this is our circuit. So now we will run the system. So once we run, okay, before we run, we also need to select this. So this one, you see, this is amplitude. So amplitude for us is let's say 400. So this is our 400 amplitude, and then this is not 60, it is frequency. So this will be for us 50 hertz. That's it. So this one 400, this is 0, this is 50, and then we apply. Okay, now we run. So we go to our output. Okay, so this is our output, which is case 1. Case 1 is balance supply voltage. So it is our normal condition. Only our load is non-linear load, and our source is balanced supply voltage, all balance. So I think you all can see that it is normally what already you saw before. So we have achieved this. So now our next target is okay, I think we need to change little bit the value, the inductor value, because I see some noise. So maybe we increase it to 0.402. Just the inductance value I am changing. Capacitor I just keep as it is. Yeah, I think now it is better. Now it's more smooth. Yeah, it's smooth. So this is the current, the voltage. So yeah, it's smooth. So we can use this. And okay, so this is the normal case study. So I don't want to run it for long. So this is the normal case study. So first you do this. So this is your case study 1. So you do it, you capture, or you already, most of you already captured. Those who didn't capture, so you capture, this is case study 1, you capture the 4 signal. Here this one 4 signal, right? So the load current, injected current, supply voltage. So you capture according to the previous videos, and also you take the total harmonic distortion THD, also it was in the previous video. So the second case study is we want to introduce a harmonic. So we double click this programmable voltage source and we just introduce harmonic. So we just press it harmonic and we just apply, okay, and then we run it. So now you will see that our supply voltage will change. There will be some harmonic in the supply voltage. Yes, so now you see from this point, now our supply voltage is changed. So there is a supply voltage harmonic in it. But you see our supply voltage is still sinusoidal. So that is just some justification we want to give, that even though our supply voltage was distorted, but still we can supply sinusoidal sinusoidal source current. Means our injection current was accurate. Our injection current was accurate even if the source voltage is distorted. So this is your second case study. So I don't want to run it completely. Same thing for this case study, you capture all the signal. So I stop it. And finally, the third case study is what I want to do. I want to do unbalance. So what I do, I just change the resistance value. Inductance I keep as it is. So now I will increase the voltage to make some drop. So let's say I make it 10 ohm for phase A. Phase B, let's say 30 ohm, and phase C I make it 50 ohm. Okay, so these three I change, so now it becomes unbalanced. So when we run, so you can already see that the amplitude already changed in the supply voltage. So the amplitude already changed. So this is we call unbalanced. So this is your case study 3 for unbalanced voltage. Okay, sorry. So this one actually yes. I think no need. So okay. So here we do the unbalance, but in case study 3 we don't need harmonic. So I will just untick. So case study 3 only unbalance is sufficient. Case study 2 only balance harmonic. Okay, balance harmonic. So now it is only unbalanced, we don't need harmonic here. And then we run. So now you will see that yes, now it is balanced, unbalanced but no harmonic, unbalanced sine wave. So this is your case study 3. Actually I think we can make a case study 4 also, just to impress the reviewers, the panel. So what we do now, it is unbalanced, also we add the harmonic. So now it will be case study 4. Let's say this is called case study 4. So now we have unbalanced and harmonic. So means two power quality problem. So now you will see that it will be a combination of unbalance. Okay, yes. So the unbalance happen, and also you will see now it will be distorted. So unbalanced, distorted. So two power quality problem we implement together. Okay. So now what you need to do is you capture all these 4 case study picture and you just put it in your paper. So actually why we are doing it, increasing more case study, just so that we can show more result and the panel can be say, okay, you have done enough study. Otherwise our work study is very simple. So I think that's all. So just check this video and produce this result from 4 case study. So what we did, we just changed our source. Previously this was our source, now our source is this one, and we just add a RL. And so I think you already noticed in the first case study the RL should be a very small value, And the second case study also same, we just change the harmonic, means we just tick this part. So first case study it will be untick, second case study tick, third case study also untick, but third case study we just increase the R and L, sorry, only the R resistance, because to produce the unbalanced sine wave. And then the final case study 4 is just harmonic and unbalanced together. So that's all. Okay, thank you.